We would like to thank LIFO and the Wizards of Ord for sponsoring Technically Bitcoin. You know, we're super happy about that. Obviously, working with LIFO. LIFO is a great contributor to the Bitcoin and Ordinals ecosystem, and so we're just super excited to be working with him, and super excited that he is supporting Technical Bitcoin so that we can make it better, so that we can make more edits, we can make it hopefully more attractive and more educational for everybody. So, would love to thank LIFO again. And Tyler, please, feel free to chime in here as well.
Yeah, no, huge shout out to LIFO. He's been in Ordinals since the beginning. I think Wizards of Ord, his other collections, they really embody the Bitcoin ethos, which is my favorite part of Ordinals. I say it over and over again, and it remains true. So we're really grateful to LIFO, the entire Wizards of Ord community, for that generous donation to help us pay our editor to keep producing these things. It really means a lot to see that validation come from the community. So thank you again to Wizards of Ord, and we're really excited to continue producing these for you all.
What's up, everybody? Welcome back. Technically, Bitcoin is back after a slight pause. I was actually traveling for the past 3 weeks, so it's my fault. But Tyler, how are you doing, man?
I'm doing pretty well. I just got back from a conference in Atlanta. Actually, it was really fun. It's called TabConf. It's like a developer-focused conference, but had some good OpCat conversations, feeling refreshed and energized about the potential for OpCat after coming out of there.
So you saying it's happening, huh? That's what you're saying?
Oh yeah, it's happening. It's happening. Sooner than everyone thinks and later than everyone would like.
Okay, well, I get it. Okay, so we cannot get any alpha from you. Okay, well, you have the best teacher, I guess. Udi is the best teacher when it comes to not sharing any alpha, just getting everybody hyped and excited. But that's all good. That's not the purpose of this episode. We're not going to talk about OpCat today. We have already covered that in the previous episode. So if you guys want to check that out, you can definitely do so. But today we're going to talk about some more basics of Bitcoin. We're going to talk about addresses, Bitcoin addresses, different types, how they came to be, and how they're different from one another. And I think this is pretty important because you guys come across this issue, quote unquote issue. Some people complain about it, that in Ordinals, in Runes, we have different types of addresses. For instance, in Xverse, you have 2 different addresses. One for your payments, Bitcoin payments, and sending Bitcoin, paying for stuff. And the other one for collecting all of your collectibles and collecting all of your meme coins and stuff like that. And so we're going to kind of explain today why we have different types and why is it even important. We can obviously dive into it. And, I think one last thing that I want to say before I hand it over to Tyler is that if you didn't check our very first episode of Technically Bitcoin, which covered UTXOs, you should definitely do it because it's very much connected to addresses and it's really the backbone of how Bitcoin works. So go check it out. We can link it up in the description or maybe put some QR code. Our producer maybe can put some QR code to the first episode in this video, but you should definitely go check it out. So Tyler, how do we kick this off?
Yeah, so I think today we're going to try and get back to our basic roots here, see if we can teach you something in less than 20 minutes. I feel like we've been getting really complex in some of these other episodes, and Jan and I have just been hearing there's a lot of new people coming into the space. There's a lot of excitement. And so I wanted to talk about addresses because I think it's one of the most confusing things if you're coming from Solana or Ethereum or you're just new to Bitcoin and you show up and you're like, why do I have multiple addresses and why are different things going different places? So wanted to take today to just really try and dispel some of that and give you a sense of where we're coming from in Bitcoin and why these different addresses exist. So we'll do a quick overview of just what an address is, and then we'll talk about the address types and then try and wrap it up. All right, so put very simply, addresses are a human-readable representation of the spending conditions on your Bitcoin. And so I think to talk about this, we actually want to go back to our UTXO roots here, and why don't we draw up we'll even draw up a couple UTXOs. So, here's one. We always give Jan 1 Bitcoin because he's got the big bags. And
make us rich, okay? Make us rich, Tyler.
Yeah. Address Jan. We're taking sponsorships, 10 Bitcoin per episode. So if anyone wants to reach out, we're listening. And I always have less than Jan because I'm a poor PhD student. So we'll give me 0.1 BTC, and we'll call this address Tyler. And just to make sure we remember how this works, we'll give Jan a little we'll give him a little extra down here too. So we'll do 0.1 BTC, and this address will also be Jan, right? So the thing to note here is that Jan, you have 2 UTXOs in the same address, right? And we talked about this last time, how UTXOs are the thing that Bitcoin is tracking. So if you looked in a wallet, right? If you looked in Xverse over here, and let's say this was your wallet view, this would display 1.1 BTC, right? Because you have a total of 1.1 BTC on the UTXOs you own, but you have 2 different UTXOs. Meanwhile, I'm over here. I'm a little bit poor. I only have 1/10 of a Bitcoin. Now, what this address actually is, it's a thing called a script pub key that then you take and you make it human readable. And what a script pub key really is it is basically the lock on your Bitcoin. So you can think of this, I don't know if I can properly draw a lock, but here's the lock on your Bitcoin. Your address describes this lock. And then when you want to spend your Bitcoin, you have to come along and you have to provide a key that lets you open up this address. So this is like the key is essentially your signature. So you're signing to spend the Bitcoin. And so, Jan, if you wanted to spend your 2 UTXOs, for each UTXO, you have to provide a signature, right? So even though they're in the same address, each time you want to spend a UTXO, you basically have to say, I have the key that unlocks this address. And that's all these addresses are. They're just these human readable representations of who's allowed to spend Bitcoin. So really you can think of this, this 32BA over here. You can really think of this as just saying, Jan's signature required. And as long as, Jan, you provide your signature, the Bitcoin can go wherever you want. And that's really all the address is saying.
And that basically means, just to simplify it, in the terms of like user experience here, it means that I have basically access to this wallet. I have the seed phrase, I have the private key, so that I can actually use it, go and sign a transaction to prove that I am the owner of this Bitcoin, or that I can actually like fulfill this lock requirements, right?
Yeah, exactly. I think that's a good point, and we'll do a follow-up episode on wallets. But when you get a new wallet, to give you some intuition, you get this seed phrase. That seed phrase is a representation of your private key. And so when we say you need a key that unlocks, the Bitcoin stuck at this address, when you generate a new wallet, they basically create this locking script. They give you a lock, and then they give you the key. And they say, here's your key, don't lose this. If you lose this, whoever has it can unlock your Bitcoin. And so that's why we don't want to give away our private keys. I think the natural follow-up question is basically, well, Tyler, why are there 2 different addresses here, right? One says Bitcoin, one says ordinals. If I'm coming from Ethereum or Solana or a standard bank account, I'm like, why do I need different addresses, right?
Yeah.
I'm me. I'm Tyler. You said my signature is required. So what gives here? Why are these different?
It looks like a
All
lot
right.
of different addresses, Tyler. What the hell is going on?
I was just thinking, what's the best way to present this? Because there's a lot going on here. So, it's actually pretty interesting. What we're going to go through is actually the history of some of Bitcoin's most important changes, because each of these changes in address type, so pay to public key was the very first address type, each one after that required something called a soft fork. And if you're not familiar with soft forks, they're fascinating. They're the way Bitcoin's upgrades, and that's actually what we're trying to push for with Opcat. So there's lots of good resources. Go Google Bitcoin soft forks. You'll find a lot of things out there. But for today, let's stick with the addresses, and let's talk about where we came from. So when Satoshi first made Bitcoin, the only type of address was this first one here. It was called pay to public key. And when we talked about, when you create a wallet, you get a public key and a private key, and the public key was a form of the address. Well, when we first started, we just put the address directly on chain, right? This is like you taking your email address today and blasting it out to everyone every time an email is sent. And anyone who uses, Gmail can see all the emails that exist on Gmail. That was the equivalent of what Bitcoin was doing in the beginning. And so these addresses, I think we can talk a bit about the like what they started with, so how you can identify them. So I'll call this the identifier. The identifier for these addresses could be anything. Any letter, any number. They were 64 digits long. And so you can imagine this is actually very unwieldy. So this could have looked like something like 0B87A like EZY2. And there are 64 of these characters. And this was very unwieldy, because if I wanted to send you, Jan, some Bitcoin, I'd be like, great, Jan, send me your address. And you'd send me the 64 digit thing, and I'd have to hope I didn't fuck up any one of these digits. There was no checks against this, right? If I read this E towards the end as a C and put that, Bitcoin's gone. Like, say goodbye. And so for a lot of reasons, pay to public key was just not the right not the right address to go with. And so that's been deprecated. There's very little software out there. I mean, you can still download Bitcoin Core and use it, obviously, and that's a cool thing about Bitcoin is you can always use the older address types, but no software really uses it anymore for the reasons we just talked about. So the next address type that came along is called pay to public key hash. And some nice things happened here. One is all of these addresses start with a 1. So it's very easy to tell if you're getting pay to public key hash. And the way you would construct it is you would take this public key up here, and you'd hash it, and then at the end of it, you'd add something cool called a checksum. And what that did is it basically said, hey, we're going to add this thing at the end where, Jan, if you accidentally changed that E to a C in the previous address, your Bitcoin was gone. Like there's nothing that will yell at you. Now we're going to add these 4 bytes at the end that will say, hey, we noticed that this address, like, it doesn't compute, right? We're basically comparing what we expect and this thing at the end, and these don't match up, so I think you messed up one of your characters somewhere in here. And so this was a very nice update to Bitcoin, where now people were less likely to just send their Bitcoin off into the ether and send it to some address that might have been unspendable. So that was a big upgrade, right? The second big upgrade here was that we got some degree of privacy. And so now when you were, if I said, "Hey, send the Bitcoin here," I'm no longer broadcasting my email everywhere. I'm broadcasting a hash of my email. And so while you could see, hey, all this Bitcoin is going to the same place, I don't know your public key, and that's kind of nice. One, it's hidden, and two, I guess this is kind of a fun fact, but the reason you want it hidden is you don't want people to be able to like try and hack your Bitcoin address via, a very powerful computer or something like that. If you knew the public key, then you can start just trying going and finding like, can I actually just randomly generate this key, the private key that goes with it? So now it's hidden behind a hash. It's a lot harder to do this. So you get, a little degree of privacy, and you get a little bit more security with this upgrade. So like, I'm just going to say this is like, what did we get out of this address upgrade? So we got privacy, and I'll say a little more security.
How quickly did this happen? So we first had the pay to public key for how many years, or was it something that was changed relatively quickly because of this reason?
Yeah, it was changed relatively quickly. I'm going to say probably around 2010. But I would need to, let me see if I can pull that up real fast. Yeah, it was activated in, wow. So January 16th, 2009. So block 728. So it was available from the very beginning of Bitcoin, but then no one was using it. And then very quickly people were like, we should use this pay to public key hash instead of just pay to public key.
Makes a lot of sense. Yep.
Yeah. So that was the first time we saw the address show up. So very quickly into Bitcoin's existence, we realized this is a much better choice. All right. So after pay to public key hash, people realized that, hey, sometimes I want to share my UTXO with Jan, or maybe I want to share it with 5 other people. And pay to public key hash and pay to public key don't solve this, because they say only one person, like only one private key, is the owner of this Bitcoin. And so Bitcoin devs came along and they said, well, we can solve this. We're going to do this thing called pay to script hash. And what this allowed you to do is basically put these more complex spending conditions in script. So now, as before, we could only say, Jan, like, give me the private key. If you consign this, then it's yours. Now we can do things like, hey, Tyler, Jan, and Udi all own this UTXO, and all 3 of them have to sign before it can go anywhere. And so this was a revelation for Bitcoin in terms of UTXO ownership and in terms of just security in general and how we can move around. So these addresses all start with a 3. And you'll notice one of the Xverse addresses is a pay to script hash type address. It actually has what we'll talk about next nested inside of it. So it's kind of fun. But what we really got out of this address type, I would say, is multi-sigs. So, we came in, only one person could own the Bitcoin. When we come out of pay to script hash now, lots of people can own Bitcoin.
Amazing. Yeah, it opened the doors to multi-sigs on Bitcoin. I think that's pretty clear.
Perfect. All right. So next, I see I haven't left myself much room here, but number 4, pay to witness public key hash and pay to witness script hash. This is what's known as Segwit. So Segwit stands for segregated witness. That's why you see witness in both of the names here. And these are fun. These all start with BC1Q. So why did Segwit addresses come about? Well, if you're a Bitcoin historian, you might have heard of something called the block size wars. This was basically Bitcoin's brutal, violent, bloody civil war. I think at some point it did literally lead to punches being thrown about whether we should increase the block size of Bitcoin or keep the block size smaller. So if you're out there degening, the block size is basically the thing that says, here's how much transaction data can go into each block. And at the end of this bloody civil war, the camp called the small blockers won. And the small blockers wanted to keep Bitcoin's block size smaller. But they said, you know what, we're going to have a little consolation prize for the big blockers. We're going to separate out what was called the signature and the witness data. And if we do that, we're going to actually charge differently, basically, when you put these on chain based off if it's a signature data or if it's witness data. So to give you a real concrete example of that, in an ordinals transaction, which comes from a Taproot address, we'll talk about that next, but in an ordinals transaction, the signature basically signs and says, hey, I'm like validating the spend of this UTXO. The witness data is all of the JPEG data you're putting on chain. And what the small blockers said is that they said, witness data will only cost 1/4 the amount of space or size as it actually takes up. And so that's how we ended up being able to do things like eventually get a 4 megabyte wizard on chain. So we use these things called VBytes instead of bytes. I encourage you to go watch our mempool episode if you want to learn more about how those are different, weight units, VBytes, bytes, all of that stuff. But for now, I think what you really need to know is that Segwit was essentially the outcome of this political fight. It gave us some efficiency gains in terms of how we're able to spend Bitcoin and receive Bitcoin. And I'd say at the end of the day, what we got was more transaction data on chain. So we basically got slightly bigger blocks, even though the small blockers won. So Taproot is where we are today. Going back to our example in the beginning, it's where you'll see your ordinals or runes balances stored in Xverse. And these, you'll notice, start with BC1P. So if you see an address that starts with BC1P, you know that it's a Taproot address. And what did we get out of Taproot? Taproot, I think the best analogy for Taproot is if Bitcoin were a car, going from Segwit to Taproot was like ripping the engine out of the car and putting in a new engine. That is essentially what Taproot did for Bitcoin. So Taproot completely changed the signature scheme that Bitcoin used before it used something called ECDSA, and then it moved to these things called Schnorr signatures. That's actually a fun rabbit hole to run down. Bitcoin would have used Schnorr signatures from the beginning, but Schnorr is an asshole who patented his signature scheme. And so ECDSA was like the workaround that everyone had to use until the patent on Schnorr signatures ran out. The other thing it did was it made it very easy to put lots of different spending conditions on your Bitcoin. So whereas before, it was very challenging to say like, hey, I want to have my Bitcoin have a bunch of ors to it, right? Tyler and Jan can spend it, or Udi can spend it, or, if you can solve this crazy math problem, you can spend it. With pay to script hash and Segwit, you had to put all of those conditions in a script at once. So as you're building up your lockbox, it's getting bigger and bigger with each of these conditions. What Taproot did is it used something called Merkle trees, which we also have an episode on. And it basically said, we're going to spread out these conditions. And so now when you want to use one of them, all you have to put on chain is that condition itself. So now instead of having like one giant vault with all of these spin conditions in it, we basically broken it down into a bunch of different smaller locks. And when you want to spend your Bitcoin, you only have to unlock one of them. And you just say, here's, I want to unlock lock number 10. Here is lock number 10, and here's the key that opens it. And no one learns about what the other, 9 locks are that you had that you could have used. And so Taproot 1, it gave us privacy. because now I don't have to reveal all the different spin conditions I have on my Bitcoin. 2, it gave us a more efficient signature scheme. So Schnorr is just a flat out more efficient signature scheme. And 3, it actually gave us a lot more efficient multi-sigs. So Schnorr is, the signature scheme is really good at combining a bunch of signatures together. And it makes it really cheap and easy to do that. So whereas pay to script hash and Segwit are expensive to do multi-sig, Taproot made it really cheap to do multi-sig. And so that was kind of the impetus to do Taproot. Now, what did we get out of Taproot? There was one other fun thing we got out of Taproot, and that was Taproot removed the size limit on the witness data. So before Taproot in Segwit, I think it was a 1 megabyte limit on the size of the witness data, and Taproot said, we're getting rid of that. Put as much data as you can fit in a block in a single transaction if that's what you want to do. And that is how we ended up with the Taproot wizards, February of last year, tossing a 4 megabyte wizard onto Bitcoin and causing a lot of havoc since. So that's kind of the overview of Taproot, and the Ordinals protocol was built based off of Taproot. So if you want to create a new inscription, you have to do that from a Taproot address. So I think that's something that's important to know, and like why you might see all your ordinals being stored in a Taproot address. What's fun is once you've created your inscription, you can actually send your ordinals around to any of these addresses, right? I could actually go,
yes,
if I wanted to, and spin up my Bitcoin core node, and Jan, I could give you a pay to public key address. And once you've made it in your Taproot address, you could send it to me there. I could send it back to you, and like, that's totally cool. That's totally valid. Now, if you wanted to create an ordinal in the pay to public key address, that's not possible, right? We don't have all the capabilities that you need from Taproot to do that. We don't have this witness separation. We don't have the 4 megabyte, basically data you can shove on a chain. Those instructions just don't exist in that type of address. And so you can think of it as we go down this list of each of these address types gets a little more and more complex, and it gives you, the Bitcoiner, more and more options for how you want to store your Bitcoin and the spending conditions you want to put on it.
This is great. This is a great summary. I think, at the end of the day, ordinals and runes and everything, it's just Bitcoin, right? It's you're sending around, some sort of like UTXO, right? And so, that's why you can send it to any of these addresses. But, as you said, Tyler, like, if you really want to kind of navigate these things, if you want to create inscriptions, if you really want to kind of, be active builder and, creator in this ecosystem, you only have to care about the 5 and 4, right? Because the Taproot is what it's built around and what is kind of established for even storing your ordinals, storing your runes, BRC20 tokens, and everything else. And then, the native Segwit or nested Segwit kind of established for anything payments related, that's kind of even the standard that, is the most established right now when it comes to the ecosystem. Maybe, do you want to do a summary real quick, Tyler? Do you want to do a quick 30-second summary of the episode? But I think we have covered everything we wanted to cover.
All right. So, class, what did we learn today? Hopefully, we learned that Bitcoin addresses are just human-readable representations of the constraints of spending our Bitcoin, right? So, addresses are basically a representation of the lock that we have on our Bitcoin UTXO, and your job is to show up with a key if you want to spend it. We ran through basically the history of address types, and I think, like, as you're out there in the wild, you can refer back to the previous slide and you can see, oh, okay, like there are 4 primary prefixes on Bitcoin addresses. So let me see what mine starts with, and now I know. If it starts with a 1, pay to public key hash. Starts with a 3, pay to script hash. BC1Q, Segwit, BC1P, Taproot, right? And each of these were soft forks in Bitcoin's history that caused some type of upgrade to Bitcoin. So these new address types really came about from a need to use Bitcoin in a different way than we were able to prior. And then finally, I think this is like, we are Ordinals fans after all. Taproot addresses, so the BC1P, are the ones that are required to create inscriptions. So that's why we see Taproot thrown around everywhere. That's why we are literally called the Taproot Wizards, because Taproot enabled inscriptions. Now, once you made the inscription, don't fear, it can go to any type of address. So if you see it in another address type, that's okay. Hopefully your wallet software is managing it right, but if they're not, stop using it, but they very well may be. So don't be alarmed if, in some cases you're like, why is this wallet storing things in a nested Segwit and a Taproot address, whereas this one's storing it all in a Segwit address, right? Each wallet can do this and manage this just fine. And so that was the big thing we wanted to dispel today, is we can manage our Bitcoin well from all of these addresses. And it's really up to the wallet to say, here's how I'm going to approach that.
Amazing. Thank you so much, Tyler, for, going through this topic for another episode of Technically Bitcoin. I think that's very educational. Guys, if you have any questions, if you have any suggestions, anything that you think maybe wasn't so clear, you would like to double down, or you would like to just clarify, you can always find us online. You can tweet at us. We have a Twitter account, X account, Technically Bitcoin, and we're also pretty much online all the time. So you can find us through DMs on X, Twitter, Telegram, Discord, everywhere. So feel free to reach out. But in the meantime, thank you so much for joining, and we're going to see you next time.
Bye, everyone.